So good afternoon, everyone. So today, on behalf of Unit 2, we'll be presenting a clinical grand round on developmental origins of obesity, from fatalism to mitigation. So this CGR will be divided into four major parts. The first is the concept of developmental origins. The second is we talk about the Indian story of the Indian studies and what is the background in which we conducted our work. So subsequently, we'll be presenting our work, which will be presented by two of the DMSRs of our division. And the last part will be the concluding part on focusing on opportunities from fatalism to mitigation. So what is the concept of DOHAD? DOHAD, or the developmental origins of health and disease, it means that early life events shape long-term health and disease risk. So our genes plus the environmental stimuli that we receive, they shape our development akin to the wet clay being shaped by the potter's wheel. So there is a developmental plasticity, particularly in early stages of life, where the organism can develop in various ways depending on the particular environment or setting. Exposure to suboptimal conditions during critical periods of growth and development can produce long-term subtle irreversible changes in the development, structure, and function of various organs like the skeletal muscle, pancreas, and kidney, which is mediated by changes in gene expression or cell differentiation. And these adaptations, although they confer short-term benefits, but they potentially increase the likelihood of diseases in adults. So there are various explanations which have been proposed for the DOHAD concept. One of the first hypotheses was given by Neal in 1962, and he said that there are certain 50 genes which enable efficient processing of food so that fat is deposited during abundance, and then during periods of famine, this deposited fat would confer a survival benefit. But of course, as the food supply became abundant, then these genes have become detrimental. The second and perhaps the most widely known hypothesis is Barker's hypothesis given by David Barker and Nicholas Hales in 1992, which is known as the thrifty phenotype hypothesis. And it says that if a fetus is constrained during the in utero period because of maternal undernutrition, placental insufficiency, then it economizes its resources. It diverts nutrients to the brain at the expense of non-essential organs. So the loss of number is there in pancreatic beta cells, nephrons, and cardiomyocytes, and there are other irreversible physiological changes, which again are short-term. In the short term, they are beneficial, but in the long term, they are detrimental. The next hypothesis was growth acceleration hypothesis by Dr. Atul Singhal and Lucas from UK. And they said that the main problem was not in the fetal growth restriction, but rather in the catch-up growth. So if there is a very fast growth, especially during early infancy, it was seen to reduce lifespan in experimental studies. In fact, many of you would be aware now there are several studies in which some degree of starvation actually improves the lifespan of an organism. So they found that 20% risk of being overweight in childhood is attributable to weight gain in the highest food diet during infancy. And sort of a hypothesis which combined the fetal growth restriction with the catch-up growth hypothesis was the predictive adaptive mismatch hypothesis by Hansen and Luckman. So it said that fetus responds to poor nutrition and metabolite perturbations by developing responses which are beneficial for current as well as later survival, provided that the environment which it is encountering in utero is similar to the later environment. But of course, when the later environment is not as predicted by the in utero, that is the constraints don't persist, then this mismatch leads to disease. So now we know that besides the constrained pathway, that is maternal undernutrition, prematurity, fetal growth restriction, maternal smoking, there is also a pathway of excess, where right from in utero period, the fetus is exposed to excess. So maternal obesity, gestational diabetes, then in infancy, excessive infant formula feeding, early weaning, all of these lead to increased obesity and cardiometabolic risk. And there are a myriad of exposures which may not be reflected in birth weight. So the birth weight may be normal, But there may be various exposures that may have important implications for the health using the predictive adaptive responses. So coming to the Indian story, so as Barker's hypothesis gained a lot of sort of popularity all over the world, so several studies were started all over the world, including India. And there is now a recognition of Asian Indian phenotype. So much so that WHO also gives different BMI cutoffs for Asian Indians, because several studies have shown that South Asian ethnicity is associated with 5 to 7% higher fat at any given BMI and greater central adiposity compared to whites. So if you see the picture, this is a picture which is used in many presentations, and this shows two gentlemen, Dr. Yatkin and Dr. Yashnik. Dr. Yashnik is from Pune, Dr. Yatkin is from UK. Both had the same BMI, but with that, both had very different body fat. So 9% versus 21%. And this they labeled as the YY paradox and published in the Lancet. But this does not just reflect the differences in their ethnicity. Dr. Yatkin was a marathon runner. Dr. Yashnik was, he said that the only exercise he had was running to the lift so that it doesn't catch, close the gates before he could take it. So their diets were different. Dr. Yashnik was born overweight. So there are various other factors, but somehow this picture has also come to define a South Asian adipose phenotype. So this may be overly simplistic. There are differences in adiposity and fat distribution within the same ethnic group, and there may be several other factors that are associated with this or more favorable body composition. So, in fact, an analysis of data from a big study called the UK AIIMS study, in which they have taken various adiposity measures, including MRI scans and genetic data for ethnicity, they found that there was no difference in visceral, liver, or intramuscular fat adjusted for age and BMI between South Asians and other ethnicities. There is another sort of a terminology which has become very popular over the years, and that is thin fat Indian newborn. So this was a study done in Pune by Dr. Yashnik. So where they compared newborns from Pune and Southampton, UK. So weight, length and abdominal girths were all substantially smaller than the Indian newborns, but the subscapulars imposed were similar. So it was interpreted as a low lean and reserve fat mass. And this was considered as a striking early evidence that supported the thrifty phenotype developing right in fetal. And more than 600 citations have been received. So it has become a received wisdom that Indian newborns are born with a thin fat phenotype. So it is like a very fatalistic view or designed view that what can we do? We're born this way. Then another thing of contention is about catch-up growth in epilepsy, whether it is a friend or a foe. So this was the report from New Delhi Birth Cohort, which is, as we all know, a very popular. There are several papers from this New Delhi Birth Cohort. It was established in 1969, and the papers are predominantly by Dr. Santosh Bhargava, who was from South Germany, and Dr. H.P.S. Sachdev, who was from Nancy. So, thinness in infancy, one of the papers that they published showed this graph. This shows the age in years and the BMI SDS of people who were followed right from birth till the age of 30 years. So they were followed intermittently, and then these dots were joined. So they said that those who had either impaired glucose tolerance or diabetes at the age of 30, when their BMI SDS were plotted, they found that they were born at a slightly lower BMI SDS compared to the general population. Then they had further undernutrition in infancy, and subsequently had upward crossing of BMI SDS. They still did not become obese, but they had this upward crossing later. So that the interpretation of the upward crossing of centroids in 0 to 2 years is. However, there are several studies from other countries which suggest that catch-up growth in infancy is probably not a very good thing. They say catch-up in weight and height does not imply full recovery at all levels. So there are studies from UK, US, Chile and Spain, which have all found that in SGA infants, there is increase in fat mass with age, and the fat to lean mass ratio is also much higher in SGA by the age of 4 years. So they said that consequent to catch-up growth, the fat mass increases more. And so catch-up growth in infancy may be associated with higher BMI, body fat, and insulin resistance in childhood. However, there is no data on actual composition of weight gain during the catch-up growth in infancy. So with this background actually, there was a time in 2008 to 10 when Dr. Vinod Paul had taken over as the head of the department, and he was very keen that all the young faculty at that time, they should identify an area and work, dive deep into that particular area of research. And we had several meetings to identify our research foci, and Dr. Bhan used to come over. And then we organized this consultation on biology of fetal growth restriction. Dr. Paul was the chair and I was the organizing secretary, and we did this. And we were fortunate to have many people who had good amount of work in this area to come over. This is Professor Ram Menon from Michigan. This is Professor Roberto Romero from NIH. He was the head of NIH in the US at that time. Dr. Yashnik from Pune. Professor Atul Singhal from UK, Dr. Shinjini, many of you remember Dr. Ramesh, Professor J.C.K. Wells, he's from UK. He has done a lot of work on hair displacement and lithography, body composition. So then we basically identified a lot of research questions and what should be our focus of research. And so the subsequent work that we did, I asked Dr. Praveen and then Dr. Priyanka to present that.
Good afternoon, everybody. So, the first study that came out in this series of publications. So, this was in 2011, where we had done a study as part of an MD thesis, where we looked at the effect of the association of early postnatal growth in low birth weight infants, term low birth weight infants. So, what we did is we had followed up about 54 newborns. Up to 7 months with a mean weight of about 2.1 kg. And as opposed to the previous studies which had done body composition through surrogate methods such as skin fold, here fat mass was actually assessed by DEXA at 7 months. And we looked at the catch-up growth in these infants at 7 months. So catch-up was defined as a change in the weight for age Z-score of more than 0.67 between the 2 time points. Now, at follow-up, we divided these infants into 3 groups. And those in red, what you see is those infants who achieved a catch-up growth by 6 weeks of age. In green, what you see is infants who achieved a catch-up growth after 6 weeks. And in blue are those infants who did not achieve catch-up. So, as you can see from this graph, if you achieved that catch-up growth within the first 1.5 months of life, you are more likely to have a higher fat mass percent when compared to the babies who did not achieve catch-up growth and who achieved catch-up growth after 6 weeks. So from this study, we understood that the earlier and greater increment in the weight for age Z-score was possibly correlating with fat mass at 7 months. Now, in 2012, this was the first birth cohort that we had done as part of a DBT funded study between 2012 to 2015, wherein 280 newborns across a wide spectrum of birth weight from 1.8 to 4 kgs was recruited, mainly from a middle socioeconomic status. And these babies were followed up at birth, at 3 months, at 1 year, and at 2 years. And over here, body composition was done by deuterium dilution method, which is a stable isotope method and a fast superior method. So, this is the first publication that came from this particular grant, where if you look at the left side, you can see the mean birth weight is about 3 kgs and the mean age at assessment was about 12 days. The mean fat mass percent amongst these infants was about 11.3%. I would just like you to just remember that number of 11.3%. And on the right, what you're seeing is that both FFM is fat-free mass, which is lean mass, and FM is fat mass. So as you can see, both fat-free mass and fat mass had correlated positively with the lean mass. But what was interesting is that if you look at this graph, you can see that across a wide spectrum of birth weight from 2 kg to 4 kgs, the fat mass remained fairly constant. So this was sort of opposed to the existing hypothesis that infants who are born low birth weight tend to conserve more fat. Now, we compared our study, the results from our study, with other publications from around the world which were published at that point, where they used different methods of body composition assessment. So, in our study, that is the orange square you see is the radioisotope method, which was used in our study, stable isotope method. And in the blue diamond is the air displacement seismography, which is currently available in our institute, and my colleague Priyanka will be talking about it. And in the gray triangles are the studies which use DEXA as a method of assessment of body composition. So, if you were to look at those, exclude those studies which use DEXA, which tend to overestimate the body composition, you can see that our study, which assessed the body of the fat mass percent at birth to be 11.3%, was sort of comparable to other studies and mainly amongst 10 studies which were done in Caucasian newborns, which is about 11 to 13.5%. So what we understood from this data was that the body composition at birth, the fat mass percent at birth in our newborns was comparable to the other published literature. Now, when these newborns were followed 2 years, what we did is that when we followed them at 2 years, we sort of assessed them based on whether they had achieved catch-up growth or not, and also whether if they were SGA or not. Now, looking at the whether with or without catch-up growth, again defined as a change in weight for age Z-score of more than 0.67. So, FMI is fat mass index and FFMI is fat-free mass index. So, FMI is an indicator of fat mass and FFMI is an indicator of lean mass. So, as you can see here, if you achieve catch-up growth by 2 years, you tend to have a slightly higher fat mass index when compared to infants who did not achieve catch-up growth at 2 years. Now, if you were to compare the two groups as those who were born SGA, that is small for gestation age, and those who were born AGA, that is appropriate for gestation age, you can see that at 2 years there was no statistically significant difference in the weight between those who were born SGA or AGA. However, if you look at the fat mass, it was almost the same between the two groups, whereas when you look at the lean mass, that is the fat-free mass, the babies born AGA had a slight advantage in terms of the lean mass. So what this told us is that the weight deficit that we saw over here was mostly due to a deficit in lean mass amongst those born SGA. In this study, we also found that the delta WAC, that the accelerated weight gain, if it occurred in the first 3 months of life, it positively correlated with fat mass at 1 year as well as 2 years. With that, I just hand over to my colleague Priyanka.
Good afternoon, everyone. So, after all these studies, we decided to use more robust techniques of body composition assessment rather than the skin bone index, which is actually used as a proxy measure for body fat estimation. So we got this machine PPOD in. So we got this machine PPOD in 2016, which actually uses whole body densitometry to determine body composition, and it provides values for fat mass and fat-free mass. It has a high level of accuracy and excellent reproducibility, and it is considered equivalent to gold standard method of hydrodensitometry for body composition assessment. There is no radiation exposure. It is safe and non-invasive. It can be used for frequent testing. And PPOD machine, this is the PPOD machine, is used for infants weighing 1 to 8 kgs, and it is now the most commonly employed technique in research involving body composition assessment globally. And this is the Watford machine, which is actually used to measure body composition for children aged more than 3 years onwards till adulthood. So, using this machine, we went ahead with our next research, which was actually a MD thesis of Dr. Asma in 2019, wherein we assessed body composition of 145 term AGA newborns. The mean birth weight of this cohort was 2.9 kgs and the mean fat was 8%. Here in this graph, you can clearly see that babies, as the birth weight was increasing from 2.7 to 3 kgs, the fat mass percentage was also increasing. So fat mass percentage, which was around 6.8 to 7% in babies who are less than 2.7 kgs, it increased to around 8% in babies who were more than 3 kgs. And in a subset of newborns whose birth weight was more than 3.3 kgs, the fat mass percentage was actually 10.8%, which is actually equivalent to the fat mass percentage which is seen in the Caucasian newborns as well. So when we compare the results of our study with the studies in Caucasians, what we found that here you can see that the bars, they are representing the birth weight, and on the top of it are written the fat mass percentage. So you can see that newborns from the Ireland, Germany, Netherlands, Italy, in all these babies, the birth weight was around 3.3 to 3.5 kgs, and the fat percentage was between 9.3 to 10.8%, which is actually higher than the fat mass percentage which was actually seen in our babies, which was around 8%, and our babies also had birth weight which was actually lower than these babies, which is around 2.8 to 3 kgs. So basically, this suggests that Indian newborns, they are not thin fat at birth. Like thin fat man has explained before this. So Indian newborns, they are not thin fat. Rather, our babies, they had lower birth weight as well as lower fat mass percentage as compared to the Caucasians. And the fat mass percentage actually increases with the birth weight. So it is probably not a function of ethnicity. It is actually a function of birth weight. So, after this study, as we all know that previous studies have suggested that intra-uterine growth restriction as well as early catch-up growth in the infancy is probably associated with higher risk of metabolic syndrome and cardiovascular diseases later in our life. So, we wanted to assess the trajectory of gain in fat and fat-free mass from birth to 6 months in term small to gestational age infants. Because in our previous studies, the SGA babies, they were actually contributing very small in number. Although we had the cohort of both AGA and SGA babies in the previous studies, but the SGA babies were smaller in number. So now this time we wanted to completely focus on small to gestational age babies. So we planned this study, which was actually a PhD thesis of Dr. Brijesh Kumar from 2019 to 2024. Herein we assess the trajectory of gain in fat and fat-free mass from birth to 6 months of age, and then we assess the effect of this particular thing on body composition at 3.5 years of age. So we enrolled 143 SGA babies from both subdivision and AIIMS, and we followed up this cohort at 6 months of age. So we could follow 109 babies from birth to 6 months of age, and what we found was that approximately 52% of the babies, 52% of the SGA babies, they had catch-up growth. And the babies who had catch-up growth, their fat mass and fat mass percentage was higher at 6 months of age as compared to the babies who did not undergo catch-up growth. Here in this graph, you can clearly see that this particular bar graph is representing the weight in grams, and the red part is showing the fat mass and the green part is showing the fat-free mass. So here, and these are the babies who did not have catch-up growth, and these are the babies who had catch-up growth. Again, the catch-up growth we defined in this cohort as well as increase in weight by more than 0.67 st between two time points. So in this graph, you can clearly see that babies who had catch-up growth, the extra gain contributed by the fat mass. And the fat free mass was comparable in both the groups. We can see from this graph. And then if you see this graph here, we wanted to see that here you can see that the x-axis is representing the delta gain in weight from 0 to 6 months of age, and the y-axis is representing the fat mass percentage at 6 months of age. So here you can see that there is a good positive correlation between the gain in weight from 0 to 6 months of age and fat mass percentage at 6 months of age. So subsequently we followed up this cohort till 3.5 years of age, and we wanted to see the growth trajectory of this cohort. So here you can see this particular graph is showing the trajectory of weight Z-score. This one is showing the length Z-score, and this one is showing the BMI Z-score. So here you can see that there was a steady increase in weight for age Z-score from 0 to 6 months of age. Subsequently, there was a decline till 2 years of age, and then there was a plateau. If you see the length for age Z-score, here you can see that again there was a steady increase till 6 months of age. Then there was a decline till 2 years of age, and the decline was more as compared to the decline which was seen in the weight Z-score, and subsequently it remained steady. So since the length for age, the decline length for age Z-score was more as compared to the weight, so BMI Z-score remains fairly constant. It is seen that it is gradually increasing. So when we compare the fat mass percentage of this cohort with the other studies, so this red line is showing the trajectory of fat mass percentage of our cohort, and the other graphs they are showing the trajectory of fat mass percentage which is seen in other studies. So here you can see that the trajectory is almost similar to the trajectory which is seen in other studies, and our babies, since they were SGA, so the fat mass percentage is lower as compared to the other babies. So after this, the next question in our mind was whether the babies who had catch-up growth from birth to 6 months of age, was there any difference in anthropometry and body composition at 3 to 5 years of age? Those who had catch-up versus those who did not have catch-up between birth to 6 months of age. So what we found was that the babies who had catch-up growth from birth to 6 months of age, there was a significant difference in terms of weight for age Z-score between the two groups, but there was no significant difference in terms of height and the body composition. So this probably suggests that the weight catch-up growth which was seen between 0 to 6 months in this term SG cohort from the low socioeconomic status, in them the weight catch-up growth, it protected against wasting at 3 to 5 years of age, but there was no protection with respect to the stunting. Also, there was no significant difference in terms of body composition. Then we wanted to see that whether there is any effect of gain in weight from birth to 6 months of age on the serum insulin levels at 3 to 5 years of age. Whether this higher gain in weight is associated with insulin resistance or not at 3 to 5 years of age. So here you can see that the x-axis is depicting the weight gain from 0 to 6 months of age, and the y-axis is representing the fat mass percentage. So y-axis is representing the fasting serum levels. So here you can see that the babies who had higher gain in weight from birth to 6 months of age, their serum levels they are actually lower. So basically they do not have insulin resistance at 3 to 5 years of age. So after this study in the small gestational age babies, so next we wanted to see the growth trajectory of the preterm babies. there are previous studies who say that adults who are both preterm, they have higher risk of they have higher risk of adiposity and higher risk of cardiovascular diseases in later in their life during the adulthood. Also, there are certain studies which say that preterm babies they have a higher fat mass percentage at their term equivalent ages. So we don't actually know whether this gain in fat mass percentage in the early period till term equivalent of age, whether this persists in the childhood and later adulthood, that we don't know. So we actually wanted to see the trajectory of the healthy preterm babies from birth to childhood. So then we did this study, which was actually a ICMR funded project from 2021 till date, and the mean gestational age at enrollment was 34.4 weeks, and their mean birth weight was 2.1 kgs, and the fat mass percentage was 5.4%. So what we saw that here you can see in this graph that these babies, this is showing the blue line is showing the weight and the brown line is showing the fat mass percentage. So this is at birth and this is at the term equivalent age of these preterm babies. So here you can see that the gain in fat mass percentage, this is showing the gain in fat mass percentage and this is showing the trajectory of weight and this is trajectory of fat mass percentage. So the gain in fat mass percentage was almost 3 times till term equivalent age, which is actually similar to what is seen in the previous studies as well. So mean fat mass percentage was actually 15.5% at term equivalent age. And then we followed up this cohort at their corrected post-natal age of 3 months, 6 months, and then at 4 years of age. Just to see whether this higher gain in this gain in fat mass percentage which was seen in the early life, whether it actually persists during the childhood or not. So what we found that here you can see that we have compared preterm AGA babies with the term AGA babies. And here you can see that at day 5 to 7 of life, there is a significant difference which will obviously be there because the preterm babies they are lower in birth weight, lesser in length, and fat mass percentage is also less. But when you see them at 3 months and 6 months and at 4 years, there is no significant difference in terms of their anthropometry as well as body composition, which are depicted in terms of fat mass percentage. So in these graphs also you can see that the difference which was there at birth, it actually did not persist. So with this, I would like to hand over to Vanna ma'am. So,
So, the study that we would like to show you. So now we just shifted the focus on looking at the maternal determinants of infant adiposity. So this was actually done as part of a DA thesis. So this was a prospective cohort study where we had included 160 mother-baby diets. So we had 60 mothers with obesity and about 56 normal weight mothers, and these babies were followed up at birth at 6 weeks and at 4 to 6 months, where body composition was done by BPOD. So we had 116 babies at birth. At about 6 weeks, we had about 106 babies, and about 97 babies were followed up to 6 months, out of which 71 of them had body composition done. So when we look at what happened, what we saw at birth is that when you compare the birth weight and the body composition parameters, they were distinctly different. As in, infants born to mothers with obesity had a higher birth weight and fat mass percent when compared to normal weight mothers. But however, when we followed these babies at 6 weeks and at 6 months, we found that the initial dichotomy that we saw in terms of fat mass and weight parameters between normal weight and mothers with obesity has sort of vanished at 6 weeks. which means that whatever was the effect of maternal obesity on infant weight and body composition that was seen at birth did not extend beyond the period of early infancy. So with that, I hand over to ma'am.
So I think we try to summarize these studies. What we found that there were differences in the body composition at birth. If a baby was SGA or preterm, they typically had low birth weight and lower fat mass percentage. So first thing is that we are trying to sort of busting the thin fat Indian newborn hypothesis. Indian newborns are not thin fat. They have lower fat mass percentage, and the fat mass percentage depends on the birth weight. The second thing is that several conclusions are somehow drawn based on some initial parameters. So, sort of by seeing the trailer, sometimes the whole movie is judged, but that the movie may be wrong. So, for example, when we see the catch-up growth in SGA infants, they have very rapid increase in fat mass percentage. Similarly, preterm to term equivalent age. When people compare it with babies born at term, they say that at term equivalent age, preterm babies have almost double the fat mass percentage as compared to babies born at term. But then those differences don't persist. Similarly, maternal adiposity, so we saw a difference at birth but not later. So it means that we should not have a fatalistic view, rather things can actually change. So we have to think about mitigation and we need to apply this knowledge, right? So three important ongoing funded studies we are currently doing, and first is effect of millet legume complementary feeding intervention from 6 months to 2 years on growth and metabolic parameters in body composition in low birth weight infants, which is an RCT funded by the ICMR. In this, as these graphs were shown to you by Priyanka earlier, so we saw that when we follow HGA infants, then typically there is a growth faltering beyond 6 months. After an initial catch-up, growth faltering in weight and length, we had analyzed our own data and saw that when we see their nutrient values, there is a deficit. All these red values depict that there is a deficit. This is the RPD's data. So deficit in energy and deficit in many micronutrients. So with this, we devised a feed which was to make it more traditional and acceptable to the families. We made it millet and legume. So all feeds are either ragi based or jowar based, and they have legume in the form of either Bengal gram or some other pulse, and with no refined ingredients. So all of this, and then we are randomizing them at 6 months. All are SGA babies. So we have enrolled now, actually we have enrolled about 600 plus because the attrition may be more, and we are targeting to have data of about at least 450 babies at 2 to 2.5 years and see whether this kind of intervention improves their growth but not leading to adiposity, so improving the body composition as well. So these are some of the pics from this like mega kind of a project. Many family visits are taking place at home or they come to us and then they have to prepare these feed sachets. We are getting prepared by a reputed lab, and then the parents have to just quickly prepare it at home and take to the babies. So another one that we are doing currently is a DBT project study, which is on the genesis of the thin fat Indian phenotype, a longitudinal study in preterm SGA and HGA babies, where we are trying to understand the modifiable determinants of suboptimal body composition. So based on our own data that they are not thin fat at birth, there is a rapid weight fat gain in the early period. But what is happening in childhood? So what are the modifiable factors? This is our focus on the study. So what modifiable factors are ultimately leading to this Indian adult phenotype? And another one in which this is a AIIMS UG grant, a contemporary investigation into Asian Indian phenotype, whether it is a myth or a reality, whether it is truly Asian Indian or just that the subjects chosen were such who were sedentary, who had a bad lifestyle, bad eating habits. So we are doing this as a UG grant where actually MBBS students are being enrolled, 18 to 25-year-olds with a normal BMI, and in them we are doing body composition, fibro scan to assess liver fat, and some metabolic parameters to try to see the factors associated with higher adiposity in youth with normal BMI. So I think what we want to say is that it is physiology rather than ethnicity which drives body composition. Excess central adiposity accumulation and increased metabolic risk may be physiological findings irrespective of race or ethnicity, and especially if there is a situation of transition in the broadest possible sense. economic, demographic, diet and lifestyle, environmental exposure, and transgenerational change in body size. So studies from other low middle income countries like Uganda, Gambia, Chile, Mexico, Guatemala, they all have reported similar findings. So it's not really Asian Indian. Terminology also probably should be changed from programming to induction. And this is something which is proposed in this very recent paper also. Programming has more of a deterministic connotation. Like, okay, somebody has been programmed, now you can't change it. Whereas induction means that, okay, there is an induction, a first step has been taken, but whether there would be the next steps which will finally lead to that phenotype of disease will happen or not will be like subject to various modifications later. So the first hit, second hit framework or the multiple hit framework also talks about the same thing. There's the first hit, which is exposure experienced by the mother that induced disease vulnerabilities prior to birth. And then there are exposures encountered by the offspring after birth and throughout their lives, which determines whether somebody can have a healthy or a diseased sort of adulthood. So various preventive measures can be taken, right from life course approach to antenatal care and to infancy and childhood interventions. One thing to remember is that when we talk about obesity prevention, everyone doesn't start with this stage. So in animal experiments, pups which were weaned to high-fat diets had greater obesity if their mothers were also fed similar dietary frequency. So when there was a double hit, they had the phenotype of obesity. In human studies also, there are some very interesting studies. Like in this study, Danish men, they were given a high-fat overfeeding challenge, a small 5-day high-fat overfeeding challenge according to birth weight category. And insulin resistance was induced in men who were born low birth weight, but not those born with low birth weight. And in older adults in Helsinki birth cohort study, again, greater salt intake was associated with higher systolic BP only in those born with lower birth weight. So you can't escape what you have gone through in your early life, but there are chances of modifying that, modulating that. Being aware of your risk is important, but you can modify this. So although obesity prevention is a public health primary prevention measure for all, it may actually be secondary prevention and therefore at a greater hierarchy bearing more urgency and likely to pay greater dividends for those already exposed to first hits in the form of being on HGA, preterm, or to mothers with GBM or obesity. So there are several opportunities for intervention from preconception to during pregnancy to infancy, childhood, and adolescence, which can actually have a sort of terminating effect on this sort of life cycle of poor or developmental pathways. So the key takeaways would be that the concept of fetal programming due to constraints has evolved through developmental programming, that is fetal plus early life, including access, through the first hit, second hit, and life course perspective. So fatalistic or resigned views, that is born this way, ethnically predisposed, they are giving way to the understanding that humans everywhere are more similar than different. It is physiology, not ethnicity, which drives adverse body composition and risk metabolism. Infants with IUGR, they don't conserve fat in utero, fat mass percentage is proportionate to birth weight. Catch-up weight gain in SGA and preterms is primarily composed of fat mass, that is true, but it does not automatically translate into continued higher adiposity. Undernutrition in infancy may also be a second hit in the diabetes pathway, as Priyanka had shown that graph that those babies who had greater weight gain in the first 6 months, those SGA babies with greater weight gain actually had lower insulin levels in 3 to 5 years of age. So undernutrition actually may be contributing to insulin resistance. Later life influences seem to primarily dictate BMI, adiposity, and risk metabolism. Prevention is more plausible because the second hits are in the traditional public health domain. So I'll just end by acknowledging our mentors. It's Professor V.K. Paul, Lead Professor M.K. Khan, Professor Ram Menon from the University of Michigan, and Professor Singhal from University College of London. Funders, AIIMS Delhi, because our body composition equipment, our space, and of course, infants, our biggest resource are all from AIIMS, and then DPT and ICMR for their funding. and collaborators from other institutes, Dr. Harish Chirani and Dr. Pratima from Satyajit, Dr. Anurag Gupta from FLU, SGRI, our own neonatology unit and OPG unit, Dr. Naval Vikram from medicine, whom we basically whose help we take for all our fibroscan work, and Dr. Shubhadeep Karmakar, because recently we have initiated some metabolomics and proteomics work in our cohort which we are following PBT cohort. Our students, so Priyanka Khandela, of course Priyanka Gupta's asthma, Arishi had done a cohort on preterm babies, Dilip had done a follow-up at 2 to 4 years of preterm and term HD babies, Shreyash had done a follow-up of 10 years in which he looked at body composition as well as cardiometabolic fitness. In PhD, Brijesh, DM Praveen Paul, and a lot of staff who have helped at all stages and families of the recruited infants. Thank you. We'll be happy to take any questions.
First of all, congratulations to you and your entire team for the. I mean, in summary, what I can understand is this a way forward to challenge the traditional path of
Not really challenged completely, but yes, I think maybe I'm not sure whether Parker really meant that everything was predestined and you can't change it. Because initial Parker's book, if you actually read it, it's like he has taken older men and then looked at their birth weights and seen that those with lower birth weights, they are now at older age, like around 50 or so, they are more at risk of cardiometabolic conditions. He did not see their trajectories and other things. So, but to make it into a fatalistic thing that low birth weight means that you are predisposed, or more importantly, I think Asian Indian phenotype and the thin fat Indian newborn phenotype, which means Asian, okay, we are all Asian Indians, so we have this phenotype. And if we are born low birth weight and we are Asian Indians, then we are sort of already predestined, nothing can be done, we'll have cavities and have cardiometabolic disease. So I think that is the major thing that we want to challenge. We do accept that yes, being born low birth weight may predispose you to higher risks, and therefore you need to be more aware. The mothers, the families need to be more aware. But then early catch-up is probably okay. Because sometimes when we try to overdo it, then instead of preventing rapid growth, we may be just preventing flattening of the growth curve, not growing at all. And that may be possibly another factor in the pathogenesis of later life problems. In fact, we haven't done much work, so I did not include here. But now many people agree with the lean diabetes phenotype, and many adults who have a lean type 2 diabetes phenotype, they may have been born either low birth weight or they may have underwent PEM sometimes during their first few years of life. So that undernutrition in the first few years of life is also a factor that could be contributory to disturbed metabolic pathways.
lower cutoff of the preterm babies that you take.
So we basically, because our PPON machine is not in the nursery, so we generally took stable babies. So I think 1600 grams was the lower cutoff. 1600 grams and 32 weeks was the lower cutoff.
That is for more of a logistic reason. I mean,
More of logistic reasons, yeah, because they had to be transported to the lab where the PPON is kept. So that was the reason.
First of all, many congratulations for this series of studies because it's really difficult to do follow-up studies and that also with babies who otherwise don't have anything. It's difficult for them to come even when they have a disease without it.
Yes.
It's more difficult to
So that is all thanks to our team and Rajesh is sitting here and Rich is here.
So many congratulations to you and your team. So I have one question. In that study where you had taken millet legume, what was the hypothesis behind choosing millet legume in that study? So I wanted to understand that.
So basically, because we wanted to, I have seen many mothers in the OPD, especially I think the nurses from southern part of our country, who were traditionally giving ragi-based meals. And then we talked to people who were from the Punjab and Haryana belt. So there also they said, okay, jawar is good. So we thought that why only wheat or rice based? And the other thing is now, in fact, people are, if you go to any grocery store, you see many companies which are promoting this millet based. So we thought that let's do a millet based, but without adding the other sort of ingredients which can make it, additives, preservatives. So, and millets are definitely, they have some benefits in terms of they have higher protein content as compared to wheat. Glycemic index is lower. So that is another reason. And legume too, because we actually have not really added anything to make up for the nutrient deficits. Like I had shown you, we had analyzed our own data and found that infants died had deficits in iron, calcium, magnesium, many macronutrients. But when we did this feed composition, we did not really have to add the coverages of these. We were able to achieve, we wanted to give 50% of the RDA of micronutrients and 20% of the total RDA because that feed was one feed in the day. So that we were able to achieve with this millet legume mixture.
Another part is, so is it the way forward now would be that based on body composition we can decide what kind of weaning foods and weaning cereals should be introduced? Will it be a way forward?
No, I don't think so. So basically, it is in all new birth weight that from 6 months to 2 years there is a growth for time. But there are different ways to promote growth. One can be we can give them laddus and ghee and whatever, and it will improve their growth. But possibly it may lead to adverse body composition. So we thought that we want to give them a healthy kind of a diet, which should improve their growth, possibly linear growth as well, and but not at the expense of adverse body composition or adverse metabolism.
This is very inspiring. Congratulations to you and your team. So my question, one is a basic question. So how does the pre-board work? And the second one is this concept also linked to how the baby grows in utero? Are there any studies determining that?
So PPOD is based on air displacement plethysmography. So it's like if you know the gold standard method of body composition would be to burn the body and then see the composition of each components. How much has gone away as water and then amongst the solids what is water. So apart from that, the best way is considered hydrodensitometry of underwater weighing. That is, you dump somebody in a tank full of water, you see how much water the body displaces, that gives the volume of the body. And then weight, and you know the weight, so you calculate the density of the whole body. Fat always has a fixed density. Fat density doesn't change. The density of the other components of the body, that is bone, waste, protein, muscle, everything, that there are several formulae to calculate. Again, ultimately there is some empirical calculations which are involved. But then ultimately for fat-free mass, you have different equations based on the age and the ethnicity and various other factors. So ultimately, for this air displacement, instead of water displacement, you are displacing air. So there are two chambers which are interconnected. You place the baby in one chamber. So the air is displaced, it goes into the other chamber, and how much air the baby is displacing, that gives the volume of the baby. And the weight you already measured. And then by some equations, the machine gives you the values. That's the baby. And yes, basically in utero, what the baby is accruing, fat versus lean mass. So there could be various factors which could be affecting it. Like for example, we saw that maternal BMI is one such factor. Higher maternal BMI means higher weight and higher fat. Then people have seen that gestational diabetes also leads to higher fat mass. And earlier it was thought that maternal constraint is leading to conservation of fat at the expense of fat-free mass, but we found that it does not have that. They are deficient in both fat as well as lean mass. So those are the base factors. Maternal diet or maternal body composition, there have been some studies, but no clear sort of equivocal kind of results have come in.
So when this air is displaced and you are estimating the fat-free mass, so do you also then take into account how dense the bones are? Or it does not matter in
No,
these babies?
no, it does not do that because basically the whole of the density of the body is coming from fat and fat free mass. So fat has a known density. So it's like a two compartment model. There can be in some research studies they do a four compartment model where apart from ADP you can also do DEXA in the same person but only to look at the bone density. And there are some potassium counters which can then give you the muscle mass. So that is a four compartment. then it becomes difficult in the real.
Okay.
Okay. Thank you, everybody.